Gis, karena Badan Restorasi Gambut mendapat mandat yang sangat eksplisit dari Presiden terkait bagaimana mengembalikan fungsi hidrologis secepat-cepatnya dalam landscape. Untuk itu dengan kondisi ekosistem gambut yang memang sudah banyak dimanfaatkan untuk berbagai macam kepentingan, kita punya challenge yang besar, tetapi titik temunya adalah pengetahuan dan teknologi untuk bagaimana kita bisa mengelola dan mengelola kondisi existing untuk menuju sebenarnya apa yang kita sebut sebagai ideal integrity hydrological landscape approach. Jadi kesempatan yang baik ini kita punya narasumber yang komplit, baik dari riset institut, dari universitas, dan juga dari kami implementator dari Kedeputian Implementasi dan Konstruksi serta juga Maintenance. Jadi ini kesempatan yang baik untuk kita semua mengeksplor dan juga mendiskusikan lebih dalam untuk kita bisa benar-benar menindaklanjuti apa yang menjadi mandat Badan Restorasi Gambut untuk Present Agency has a mandate, explicit mandate about how to accelerate the recovery or the hydrological function of the peatland landscape scale. So as we already know well about the Indonesia tropical peatland already had developed, and then we need to also consider many aspects of to improve or to restore physical skill. So today we would like to discuss deeply about these matters, and then we need, of course, to establish the hydrological society networking for the tropical peatland ecosystem. So for opportunities, I think can share our idea and our experience how to also using this modality for improving and continuously restoration and revetting in the especially, and then also will give the lesson learned for the tropical peatland in the others country. I think that's all my opening remarks, and thank you for your all of your
discussion. Conclusion for about 10 minutes, and the whole event will be at 4:30 p.m. Kim, it is hope that providing an opportunity for BRG partners to convey their view through question session. Professor Takahashi will explain about the state of the art of hydrological restoration research in peatland. Please, Professor Haidunuri, time is yours.
Hello.
Hello, yeah.
Hello. Yes.
Yeah, time is yours, Professor.
Yes, but wait a minute.
Okay.
I try to. Can you see this my slide?
Yes, perfect, Professor.
Okay, you can see this picture.
Yes, I can see.
Okay, so thank you very much. Good afternoon, ladies and gentlemen. Today I will speak about aspect of the carbon loss from tropical peatland. relating to the groundwater level change and the estimation of groundwater level in tropical peatland. This is in central Kalimantan Megares project area. In July, estimation of groundwater level using the hydrological characteristics of peatland. And fifth, estimation of potential of peat fire in wide area using Moody's and the JAXA Global Rainfall Watch. First, water balancing peatland. Determination index also high. So we can use this peat fire index for estimation of peat fire occurring and potential peat fire in some area. Next one about the peat decomposition. So I measured ground surface level using this instrument since 2013 and groundwater level also. So I was surprised, ground surface level decreasing year by year. And depth of decomposition looks like relating to the low groundwater level. So I calculate accumulated low groundwater level every year and compare the amount of subsidence of peat surface and accumulated low groundwater level. You can see the two items have good linear relationship with very high determination coefficient. Next is another scientist measured carbon emission from peatland forest, relationship with carbon emission and water table depth. This result after Professor Hirano. You can see the relationship water table depth and carbon emission has linear relationship. So this means water level is very important to decrease the carbon emission from peatland. And in the case of plantation, the result is same. Many scientists measured total respiration in the peatland and water table depth. So you can see many kinds of plantation also have very clear relationship with total respiration and groundwater level. So this means groundwater level keep high is very important for cut the carbon loss by decomposition of peat. And next, estimation about groundwater level using the hydrological characteristics of peatland. I use groundwater level change, daily water loss, and depth of groundwater level. And another one is rise of groundwater level by rainfall. Two equations used for estimating the groundwater level for several months. This is a water level data, groundwater level data, and rainfall data measured in West Kalimantan. I calculate the relationship using this 2.5 months data. After that, I estimate groundwater level by using the equation and rainfall data. The result of estimation is very similar with measured one. So this methodology will be useful for focusing of groundwater level change.
Excuse me, your time still 4 minutes left, Professor.
Okay, at 3 slides here. And this time I expand our research to the wide area. This is the rainfall data supplied by JAXA, Global Rainfall Watch. So we can use the digital data of wide area. So I'm using this data. I calculate distribution of peat fire index in Central Kalimantan in 2019. So you can see this area have a lot of, you can see many fire spots. Even if the peat fire index is not so high. But you can see here, this area have very high water index. Maybe peat fire potential is high, but we cannot see very few fire here because this area is conserved area and the Sebango National Park. So we can use this methodology for estimating management is good or not. Finally, I conclude determination of land use type with low carbon emission and evaluation of land management are possible by monitoring hydrological conditions on the ground and from the satellite. And finally, I add one more comment. Effort diagram of monitoring. Setting instrument is not so difficult, maybe 20% energy. But management of instrument and data is very important. Maybe we use 40%. We can without this good management of instrument and data. And analysis of data also important, using good information from
And the third publication is how temporal pattern in rainfall, geomorphology, and carbon fluxes of tropical peatland. Dr. Kopp will explain about the behavior of water level fluctuation in peatland, as well as canal blocking techniques and modeling the impact of canal blocking on the hydrological system. So please, time is yours, Dr. Kopp.
Thank you. Papa, is it possible to show my presentation? Oh, can you hear me?
Yeah.
Here we go. Okay. Thank you. Okay. So I will give a very simple presentation today. I guess I won't tell you anything that you don't already know, but I hope that maybe it presents a different perspective on the issue of hydrology of peatlands and how it is connected to the shape of peat domes, or, well, any peatlands. Next slide, please. So in my talk, I would just like to make 3 points. The first point is just that the size of the parcels that are created by rivers or canals and peatlands sets a limit on how much peat they can store. And when we create canals or ditches inside the peatland, then one way that we can understand their effect is that they reduce the limit on the peat thickness. So if we cut the peatland into smaller pieces with canals, then the peatland cannot store as much carbon. And then something you also probably know is that it is not so easy to reverse the effects of canals and ditches once they've been constructed. I'll try to talk about this from the perspective of the shape of the peat surface. So as everybody knows, I guess, peat accumulates where water logging slows down decomposition. When there is not very much oxygen available for decomposers.
Sorry, Dr. Scope. Yeah, I
Yes.
think your voice is a bit unclear. Is that
Oh.
wrong?
I'm not sure how to, let me see, I will try to find a way to make.
Do you feel it, Pak Budi? It's not very clear, right? Wait a second.
I will try to find a way to.
It's a bit like something like that.
Is it better?
Yeah, I think
Oh,
so.
yeah, is it better? Oh, okay, okay. I hope you can hear me. Okay, next slide, please. So as you probably know, over time, peat tends to accumulate into gently mounted shapes that we call peat domes. So maybe they are around 5 meters or 10 meters thick and 5 kilometers to maybe 20 kilometers across for the very, very large peat domes, like in Sabangao or Katingan. And the amount of peat that accumulates is determined partly by rain and groundwater flow. And they have to have this mounted shape because all of the rain that comes out of the sky has to flow out of the peatland. And how curved the surface is, so how much peat they can store, depends on how much rain there is and how easy it is for water to flow out of the peatland. Next slide. So one way to understand this is that there's a limit to the curvature of the peat surface, so how curved the peat surface can be. If the peat surface is too curved, then peat tends to be lost, and if the peat surface is too flat, then peat tends to accumulate. Next slide. I tried to talk louder. I think people are having difficulty hearing me. Okay. So in this slide on the left-hand side, there's a picture of a kind of flat peat dome, and on the right, there's a picture of a kind of curved peat dome. So on the left-hand side, what happens is that the water table tends to reside high, close to the surface. So decay is relatively slow, and peat accumulates to make the surface more curved. On the right-hand side, you have a more curved peat dome. The water table tends to reside low, further below the peat surface, and so decay is higher and peat is lost. Next slide. One of the implications of this is that the amount of peat that can be stored inside a drainage network depends on the size of the parcels. By parcel, I mean just an area where peat can accumulate that's bounded by water, like canals or ditches or rivers. So on the left-hand side, we have one big peat dome. if we create a canal or a ditch through the peat dome, the maximum curvature of the peat surface is still the same, but the area can't store as much peat or as much carbon because there isn't as much area for the peat to accumulate. Okay, next slide. People are having difficulty hearing me. I'm very sorry. I don't know how to improve the sound. Maybe I'll quickly try.
Yes, I don't know what it's like. It's like something. I think it's like touching your neck or something.
Oh, maybe. Let's see. Is this better? Is this clearer if I talk like this?
Yes, I think it's clear. It's clear.
It's better. Oh, okay,
Yes.
okay. Thank you. Sorry. Okay. So what this means is that the ability of the drainage network to store peat depends on the shape of the parcels in the peatland. So for example, if you have a round area for peat accumulation, then this can store the maximum amount of peat. If you have something with a more complicated boundary like this sort of potato-shaped area, then it cannot store as much peat, even if the area is the same. And similarly, if you look on the bottom right-hand side, there you have some small squares. Of course, they can't store as much peat as a big square. And a long rectangle with the same area also can't store as much peat because it's long and thin. Next slide. So here is just a drawing of how the shapes and the sizes affect how much peat can be stored inside a particular parcel. Any one of these lines represents a particular shape for a parcel for peat accumulation. Next slide. So I will just present two simple examples, one from Northwest Borneo and one from Central Kalimantan, just to parcels is related to how much peat the peatland can store. Next slide. So for example, this is in Northwest Borneo in Brunei Darussalam. And on the right-hand side, there are some natural peat domes. And on the left-hand side, is a oil palm plantation. And the color means the maximum amount of peat that can accumulate in this area in a way that's normalized by climate. So you can see that a lot more peat can be stored in these big peat domes than in the small parcels of the plantation. Next slide. So here are the plantation parcels. It's the amount of carbon they can store is several thousand times less. It's just because they're small. So the way that you can picture this is that in a particular, the curvature is the same in both cases, but the area is small, and so the maximum height of the water table in the peat cannot be very high above the water level in the ditches or canals. Next slide. Here's an example from Kalimantan. I'm sure probably the boundaries that I drew for the peat dome are wrong, but I think the general idea should still be clear. On the right-hand side of the former Omega Rice Project area, these blocks are the squares that are created by the canals are pretty big compared to a plantation, but they're very small compared to the peat domes in Sabanga or Katingan. And so the area just can't store very much peat above the level of canals and ditches in this configuration. Next slide. Former Omega Rice Project area. So the point is just that canal and ditch networks in managed peatlands cut the peatland into parcels that are small. Usually they're very small. And so in the long term, this means that these parcels just cannot store very much peat above the level of water in the ditches. So one way to picture what we are doing with rewetting is we try to recombine these cut up parcels into bigger parcels where they can accumulate more peat. Next slide. So as an example, I will talk briefly about a situation in Brunei Darussalam where there is a canal going through a peat dome that was created in the 1960s. So I'll try to show how it affects the shape of the peat dome over the long term. Next slide. and also fires every few years. But of course, as many of you also experienced, I guess, there's flooding near the canal. Next slide. So this just gives you an idea of the size and shape of the peat dome. The black outline is more or less the original shape of the peat dome, and the canal was cut in the 1960s. Next slide. So this is how we could picture the maximum peat that could be stored in the peatland. The actual shape is not quite so tall, but it's close. It's maybe 13 meters thick at its deepest. Next slide. So with the canal in place, there's just no way that the area can store as much peat because we have a waterway. The canal has about the same elevation as the rivers. And there's no way that the water table can make a sharp turn right next to the canal. And so over time, we know that all of the carbon, all the peat that was in this kind of wedge-shaped area has to disappear, either by decomposition or by fire. Next slide. So we can calculate actually how much less is the maximum volume of peat, if you prefer, with or without the canal. So the canal the area can store project. But I wanted to quickly talk about something, maybe illustrate something that many of us have experienced for why it's not so easy to restore the hydrology of the peatland to what it was before the canal was created. This is just a cartoon. So maybe the initial dome shape looks something like this. Next slide. When the canal was created, it makes it cuts a slice out of the dome. Next slide. And so over time, if we never block the canal, then we can expect that all of the carbon or peat in the shaded area will eventually decompose or burn. So we block the canal. And that means that we try to raise the water level in the canal closer to where it was before the canal was constructed. Next slide. But unfortunately, because the canal was created about 50 years ago, there's no way that we can raise the water table to the original surface of the peat dome, because there's a wedge, maybe 300 or 400 meters wide, that we cannot block with a dam. Next slide. So this means the good thing about the canal blocking is that we can avoid the emissions that are in the green area. But unfortunately, we don't have a way to avoid losing the peat and the carbon that's in the red area, because we don't have a way to raise the water table to where it was before the canal was created. And I think this is the reason that even though we've blocked the canal, we still have recurring fires and also decomposition. I mention this because I think it's important to not be too optimistic about how well we can do this with reasonable technology. Okay, next slide. Okay, so just to conclude, one way that we can understand the carbon storage of peatlands is based on the shapes and the sizes of the area where peat can accumulate inside the peatland. When we cut a peatland into smaller pieces with canals and ditches, we can imagine that we're reducing the maximum amount of peat that the peatland can store. And it's not so easy to fully reverse the effects of canals and ditches with dams. That's all for me. Thank you.
Thank you very much your presentation, Dr. Kok. Very nice presentation. Now, for the next speakers is Professor Associate Ausamu Kozan. First, I will read his CV as follows. Associate Professor Osamu Kozan is an environmental coexistence associate professor in Center for Southeast Asian Studies, Kyoto University. His research interest is sustainability of the large-scale tree plantation in the peat swamp forest Indonesia.
Okay, thank
Yes.
you.
Please, Professor, hello.
Yeah, can you hear me?
Yes,
Okay.
Professor Professor Osamu.
Yeah.
Please, time is yours.
Okay. Thank you for giving me the Osamu Kozan from Kyoto University and Research Institute for Humanity and Nature. Introduce my activity. This photo is my C-band dual Doppler radar system to estimate rainfall system in peatland. Now located on at Bunkari City, North part of Ria province. Okay, let us move to restoration is very difficult because we need well-planned land management and planting system. So because of degraded peatland is very complicated to restore. Now we started our project in these 5 years, relating reforestation of using native species. First step is water management. Second step is breeding of native seedling and land management and wildlife habitat management also. Okay, so I'd like to discuss a little bit about tropical peatland hydrology. Problem is unique soil physical and hydrological processes, very different from mineral soil. One of the problem is water holding capacity is very low and soil moisture control is difficult and groundwater water flow is unpredictable. For example, mineral soil. 3 figures of soil physical and hydrological process in mineral soil, peatland, in rainy season and dry season. At mineral soil, surface soil moisture is connected with groundwater. Even in groundwater level, it's lower than -3 or 4 meters. But in peatland, at peatland, capacity water layer is only 20 30 centimeter, and suspended water also 30 centimeter, 40 centimeter. So big, and if groundwater level is lower than 50 or 60 centimeter, surface layer is almost no connection from groundwater, and in dry season, surface layer will be very hot and dry and sometimes easily burned. So now we use soil moisture control using trees. We plant native species who can intake, who can carry from groundwater until surface layer. This is our activity, long activity cooperated with Harris. So this activity almost more than 7 years, debating a reforestation project in desert. So at first time, at that time, almost bare land, but now we have very big trees like this, and also surface soil moisture layer is getting mild, and wind velocity also we can control wind velocity using tree and that kind of canopies. And okay, let us move to other problem. It's I respect Indonesia government activity, but unfortunately in this region, my research target area, almost no scientific data about tropical peatland management. Most biggest problem is elevation data is not so reliable, and rainfall, precipitation data also. So now we improve this situation using LiDAR data. So LiDAR data is sharing from Shinanomasu and APP group. company shares elevation and river catchment area information. So we can understand easily my research target area. This area is located on the downstream area of big river basin. And upstream area is managed by company, and company managed area is very flat. And our research target area is not so flat. So sometimes we need control water management using dam or small dam. And we installed C-band radar to estimate rainfall precipitation in peatland. Unfortunately, this area almost no reliable rain gauge, rain data. So we cannot calculate water budget without reliable data. So now we already started. Kyoto University developed this algorithm. BPPT prepare a sharing system. BPPT already share this data with local company. We can estimate restoration of entitlement also. 3R is very popular. So peatland restoration agency use this concept. And also we do 3R and 4R. 4R is restoration of entitlement. So we use entitlement. Entitlement means we promote local people's positive activities, participation to peatland restoration. As a first step, we started community water management in Tanjiraman village. There are 3 concepts. First concept, we made hydro river map cooperated with company. Gray line indicate watershed, river basin boundary. Local people, yes, understand a little bit, but not completely. So we share this information. We can see acacia plantation area on the upstream of Tanjiraman village. The village is located in the downstream area. And second concept is water management at 5 level zone, like this. So this village we divided into 5 parts. And we construct a small dam for water control. And we apply hydrological model to drought and flood forecast, like this. And we applied transdisciplinary approach with company and local villagers, local people. So first, collaboration with villagers, hydrological monitoring, management technology, and water gate canal construction. Second phase, visualizing the results, technical cooperation, villagers, government, company cooperation. Now we have monthly water management meeting almost every month. This is our project for these 5 years, that kind of activity. And now we try to understand land ownership. Land ownership is one of the important problem, because local people join this water management group activity, but some of non-villager didn't join this activity. So now we encourage the non-villagers to attend monthly water management meeting, because most of non-villager living in Pekanbaru, Dumai, and Jakarta, so very difficult to contact. But for water management, only 1, 2 small areas is almost no meaning. So now we encourage, invite non-villagers to total river management in this village. Okay, so and livelihood improvement is also our research target. So until our activity, so until 2010, so villagers bought vegetables from Dumai or other city and sell tree to middleman. So now we organize female, male villagers. Now they began to grow self-consumed crop. Participation rate is more than 25% villagers join this activity, and develop sales channel for planted trees because local people can get more benefit using that kind of. So yeah, now local children can eat has high motivation to plant vanilla or that coffee to get good money. So some of villagers send me WhatsApp. So now vanilla is one of the very popular plant vegetable in this village. So vanilla price is very high now. And also now we continue our livelihood and income analysis since 2011. So at that time, rubber is most popular, but now oil palm rate percentage is getting increased because of rubber price is getting now very low, and rubber is not so popular in this village. That kind of their livelihood. Change of their livelihood is also our research target. Okay, so this is my conclusion. So I didn't explain all our activities, so please visit our website. Our activities are open in our website. Okay, terima kasih. Thank you for your kind attention. So if I have next opportunity, I'd like to explain our activity using drone or that kind of fire monitoring cooperate with the villagers. Yeah, thank you. Terima kasih banyak.
Yes, thank you, Professor, for your nice presentation. And for the last speaker, I guess, I will give time now for the last speaker, and I would like to invite Mr. Susilo Indarto. Now, before that, I will read his CV. Mr. Susilo Indarto adalah kelompok kerja konstruksi, operasi, dan pemeliharaan. Sebelumnya, beliau menjabat sebagai Kepala Subdirektorat Pengembangan Usaha Kemasyarakatan Hutan Desa, Hutan Tanaman di Direktorat PSKL KLHK. Now, time is yours. Yes, please. Mr. Susilo.
Yeah, thank you, Mr. Budi. Good morning, good afternoon, everybody. I wish to request by community to give presentation on peatland restoration in Indonesia since 2017 to 2020. This presentation, I would like to share my experience working on peatland restoration at level, including implementasi issues issues, challenge, and how to find the adaptive solution. Please, I would like to share our presentation. Share screen. Ini dia. Yang ini kan? Nah, ini kan?
Bapak mau presentasi, mau share sendiri, Pak?
Ya, share screen sendiri.
Oh ya,
Ini kan?
di close aja Mas Ivan.
Ya, akan dibuka. Yang ini. Yes. Outline as the first is my presentation. I explain about the PRK task and function, PRK restoration approach, progress of achievement until 2019, and the last is I will provide conclusion based on my experience in the field. You know that based on presidential regulation number 1, PRK function is facility and coordination about 2.6 million hectares during 2016 and 2020. About task there are 9 tasks, especially for deputy PRK construction operation. There I have to point to value yaitu is arrangement of pitland and rewetting construction in pit and in pitland area. Pitland in 7 provide priority. Yeah, in Sumatra, Kalimantan, and Papua region, about 12.9 million hectares. You know what distribution of peatland in 7 provinces, not all of restoration, but just priority. Total priority to 7 provinces, about 5.2,000 hectares. With a criteria priority burn peatland and protected peatland with canals. About 5.2,000 hectares and selected priority just 2.6 million hectares. Planning to restoration based on planning hierarchy and peatland restoration target. Hierarchy planning has to make SED, DED, or rapid assessment. And and SED, we continue with activity plan. Activity unit analysis, annual planning, 1 PHU, jadi peatland hydrology unit, SED DID based on peer target and activity plan based on unit analysis based on activity self-managed based on activity yang will be conducted both contractual management or self-management contractual atau with villages we can do. You know what indicator of degraded peatland based on managed Indonesian Ministry of Environment and Forestry. Degraded peatland is a fire, canal drain, bar pits, groundwater level more than 0.5 meter, and pirate exposed. This is an indicator of degraded peatland in Indonesia. So BRG restoration approach to restoration foremost with 3R. R1 is reweighting of peatland. This technically to implemented by to build canal blocking, canal backfilling, and deep well. And then R2 is revegetation to cover burnt area, activities, nursery, seedling, transplantation, and natural regeneration. And then the last 3R is revitalization of local livelihood. This activity based on land-based, horticulture and cattle, water-based, aquaculture and fishery, and environmental services based on local community and development. This activity. There are 3 activities, 9 activities: reweighting of peatland, revegetation, and revitalization of local livelihood. The stake of peatland restoration planning, the first planning with target of location, requirement, survey investigation, and detail engineering. Detail engineering to build canal blocking, the step of build canal blocking. The first learn in PHU Batanghari River, air hitam laut, based on digital mapping unit, this KHG as SUP-PAN PHU, we divide through 3 sub-PHU, 1, 2, and 3. So we in the term hydrology management use PHU Batanghari, totally about ini, and sub-PHU 2, sub-PHU 3. The tabel like this. We divide 3 pitch dome, 3 dome yang one and the other independent hydrology, water hydrology. Next, we determine to sub-landscape, to get estimation supply canal and tertiary canal. Untuk we must to determine to block it. Must be planned to ensure that canal blocking is working effectively and efficiently to hold water, the flow from peak of the dome to the lower of before ending in the river or sea. Canal blocking construction began from highest to lower area. Starter canal, secondary canal, and the last the primary canal. Sheet distance type of size canal blocking affected by slope, size of canal, and flow rates. Construction canal blocking, difficult access, and weak current for convey and with spillway for the water management, and canal with gate open close to tidal area. Determine canal blocking site, To following this to be notes meant to the groundwater level, okay, to 40 centimeter at the maximum, the steeper slope, the distance between canal blocking need to be shorter and vice versa. In the implementation in field, determine to distance between canal blocking is follow. For canal width 100 meter length and slope about 2 meter, 5 canal blocking are required to maintain 0.4 meter groundwater level. And for canal with 100 meter length and the slope is 4 meter, 10 canal blocking are required to maintain 0.5 meter groundwater level. Estimation to estimate revetting impact based on the sub landscape analysis, the estimation of revetting impact from the area. For example, intervention canal, dimension canal need bigger as well, multi-layer is requirement. The accurate dimension canal blocking essentially to anticipate the force, the water flow rates, and ensure to over tuning stability. The weight of span influenced by flow rates, construction, top view, side view, and so on.
Excuse me, Pak Susilo, would you please speed up your presentation?
Ya, oke, ini bicara wooden block spillway, wooden block without and so on. This is, and we have inovasi teknik dan jenis not the pre-construction, fabrication, terus assembling, and resultnya something like this and like this. Concrete canvas block we try to design to model saw the pre-construction like this, pre-construction with canvas block, and this is the result. This canal backfilling, we can juga mix canal backfill in canal blocking and protective pitland with canal, burn pitchland, include in pitchland restoration indicator conservation zone. This is lokasi borrow pit and jam hilir and so on. We can make not with heavy duty instrument. Ini deep well we build a deep well and burn pitchland, includes in pitland restorasi indicative mapping and non-concession area. Something like this in burn area, we analysis with investigasi design. We analysis where is territorial conflict, where is fire for agricultural land preparation and natural cause and human activity. We can divide it to select it in field. So we define where is must be built and no. This is design detail engineering, non-casing, full PVC and galvanized, non-casing and with casing, full PVC and galvanized type. This is operation of deep well to when the forest burns and lain with Mr. Kabupaten to operation. Revegetation on bare land, peatland burn areas on state forest and include in restoration. Jadi we will juga revegetation and by on this many design, many model we can build it. Something in it is in Padang Sugan welfare is where we can do it. And Sungai Domain Natural Resources we can revegetation and pineapple. We can do with community nearby this location. This is sago plantation in area full water, flood water area. We can plant a specific species like sago and so on. Revitalization economy we can do when the direct impact village and undirectivity R1, R1, R2, and R3. The direct impact village is expected to be able to support the peatland ecosystem protection and prevent peatland for occurrence. And the indirect impact village is expected to be able to manage the land and water wisely by referring to the restoration principle. Ini R3 on farm, the intervention revitalisasi both on farm, on off farm, based on water, based on land, based on ecosystem services, supporting off farm, supporting program, marketing, and process market access.
Excuse me, Pak Susilo. Actually, your time is up. Would you please speed up your presentation?
Okay, this is a picture of program water basis to duck, fishery, and so on. This is program from a land basis to watermelon, cassava, and so on, and Mr. Pineapple and so on. Based on ecosystem services in Central Kalimantan, based on all of farm post harvest, we facilitate how to mengolah pineapple and so on and this is handicraft support from Purun, and this is achievement progress on rebating after 27 and 2019. This is the conclusion from experience in field. The implementation of peatland restoration cannot be done ideally, but adaptive to current dynamic use on peatland on field. Peatland restoration cannot be done partially, yet holistically based on peatland hydrology unit. Peatland restoration need to be carried out collective by all related stakeholders, such as central government, local government, concession holder, NGO, community, and university or academic. Peatland restoration cannot be done instantly. It's a process take long time and costly effort. The intact peatland must be protected, conservation conserved, and visually utilized by referring to the restoration principle, while the degraded peatland must be restored to peat rebating to maintain its groundwater level. So I think it's enough, maybe too much time, to take much time, Mr. Pak Budi. Terima kasih, thank you.
Well, thank you. Thank you very much, Mr. Susilo. Actually, this is a very interesting presentation, but time is limit. I apologize for that. Well, all the speakers have already present their presentation. Now, before I invite the speaker give any comments to the others, I would like to give a chance to Dr. Haris to give your comments to the speaker's presentation. Time is yours, Dr. Haris.
Yeah, thank you, Pak Budi. Thank you for all of the speakers. I think I enjoy to listen and then also get some idea how to use your idea and your research to also improve our effort for the restoration activities. of course, as the Deputy Research and Development, we need continuously to collect and um, go to the field land, and then we need to analyze the data scientifically. So I think I want to how can I say, to remind all of us that during almost 5 years that BRG working for the restoration, as far as you know that also Pak Susilo explanation that uh, restoration cannot be effectively in the just only partial part. So we need to consider the integrated approach. And for today, of course, we need to discuss deeply about the hydrology. So from Professor Kahasi, he mentioned about very important how to understanding about the groundwater level, and then we would like to know more from Professor Takahashi based on his long experience working on the field. And I know before I worked in at BRG, I joined also with him in the field. So as I think you know well about the existing land condition in Indonesia, and we would like to listen what the Takahashi Sensei thinking how to real the achieve. I mean that like a consensus that we can manage groundwater level in the different proposed, and also we can still maintain the peatland in the landscape scale. So we need, because but I think half of the Indonesia peatland already further development. So we cannot say that the groundwater level should be ideal for the whole of the landscape. So we need the Takahashi Sensei comment and idea how to make a deal. I mean that the groundwater level for the restoration activity. So that also important, and then to improve our groundwater level monitoring in the landscape scale, and then robust data. That I want to give the comment about the Takahashi Sensei presentation. And then for Dr. Kopp, very interesting that, but we would like to know further about what you're thinking about the achievement of the, you know that the canal, the digging canal already exists, and then if you have the data and the modeling, precise modeling in the landscape scale, so we can use to promote the model, because in Indonesia, especially under BRG mandat responsibility, we have 100.106 peatland hydrological unit. So if you have knowledge and then also science how to make a model in the landscape scale, we can promote one or two peatland hydrological unit, and then we can really use the scientific data to improve our hydrological situation or hydrological regime in the landscape scale. That's we want to also listen what you are thinking about this. And then Professor Kozan, all of participants know that Me and Professor Kozan already, how can I say, work in the field work also a long time, almost 15 years, and he know well about the very difficult, and he said that we don't have scientific data, but we have to walk, we have to do quickly, so we cannot wait completely scientific data. So I want to know, Dr. Kozan, comment about, yeah, we can really work together, scientific and action. We call the research action. That's important because we cannot wait for the completely scientific data and analysis, but we have to also how to use gradually our experience and our scientific data to do the real action, and then improve our approach for the restoration, and then also to improve the other purpose of the restoration, as you mentioned about the livelihood, because we cannot wait for perfect concept and perfect data and scientific, but we need of course your experience to also to, how can I say, to make like Tanjung Leban or Bengkalis experience, to upscaling to the other the Tanjung Leban or the Bengkalis experience to very useful for action restoration action in the other area. I think Pak Kozan would like to also give us his experience, how to also engage the many stakeholder, because very important, because if just only walk in the village level, I think we cannot get the water from the other area. So I think we need also Pak Kozan mentioned about this. We need to collaboration about the water collaboration, not only how can I say, not only the one of the other aspect of the collaboration. And then Pak Susilo, I think we got the idea that Pak Susilo and team working about the restoration. We call like a quick response. This is how to he mentioned about the adaptive, because we would like to know that to understanding and to invite as many as stakeholder to understand about our goal about of restoration also take a process, and takes a time. But I think the modality of Pak Susilo working, I think can also using for the future restoration activities, and then we always to improve, and then using this information for our goal of the restoration, that we can manage at the landscape scale of the wetland ecosystem. I think that's all, Pak Budi. My comment, Pak Budi. Thank you for all of speakers.
Thank you very much, Dr. Harris. I think you have already give a complete comments to all of the speakers. Now I think it's about time for the first speaker give any comment, any suggestion regarding to the other speaker's presentation. Please, time is yours, Professor Heidenori Takahashi.
Okay.
Yep.
Can you hear my voice?
Dia bingung Pak mau apa itu.
No, I think you can use your time to give any comments or any suggestion regarding to other speakers' presentation. You have 5 minutes for that. So please. Or maybe you can give any suggestion maybe. beside comments?
Okay. Can you hear my voice?
Yes.
Okay. I think I have a long time experience for studying tropical peatland in Indonesia. I think fundamentally management of peatland is keep balance carbon accumulation and carbon loss. So I mean, most of tropical peatland forest get carbon through its accumulation controlled by no canal construction. So fundamentally, recovering the forest and stop the carbon loss from peatland is canal blocking. It is very important, but I saw a lot of area already used for agriculture and another purpose, plantation, including plantation. In such a case, carbon cannot accumulate on the ground. So how to stop carbon release from the ground is important in such an area. So, and one more important is how organic material supply on the ground by planting or some agricultural activity. So carbon balance keep by water management and vegetation recovering or organic material supply on the ground. This is a very basic concept for keeping peat in good condition. And we know another problem is peat fire. Peat fire occur by lowering of groundwater level. But human impact is also very serious near the village. So peat fire management by local people is also very important. So water management and organic material supply on the ground and peat fire management is very important for tropical peatland management and stop the carbon release from the tropical peatland, I think. This is my fundamental idea and comment. It's okay?
Okay. As you finish?
Okay.
Yeah. Thank you for your comments, Professor. Then I will give the opportunity to Dr. Alexander Kopp to give any comments or any suggestion regarding to the other speaker presentation. Your time is 5 minutes. Please, Dr. Kopp.
Thank you. Can you hear me this time?
Yes. Clear.
Yeah, sorry about that with my microphone. I have two. I think I have many questions, but I'll ask two questions. I think my first question is for Professor Takahashi. I really enjoyed learning about your way of predicting the water level in the peatland. I was curious about for the the peatland fire index in the map that you showed. I saw that you have a parameter in the model, I think that was determined by some empirical data by the water level. I was wondering if you use different parameters at different places. So for example, are there different parameters in Sabangao than in other parts of the area that you're studying? And then I have one more question for Professor Kozan. I was curious about in one of your slides, you showed the size of the capillary zone in the peat. There was on the left-hand side, there was under wet condition, and in the right-hand side under dry condition. You had a particular thickness for the capillary zone, I think 20 centimeters. And I was wondering if you have measured this in the field, and whether this is something that you have published or would like to publish. I think that's it for the questions for me.
Thank you, Dr. Kopp. I think Professor Takahashi and Professor Osamu Kozan, just keep your answer for the to answer the question from Dr. Kopp. But I will give opportunity to Professor Kozan first to give any comment, any suggestion or question maybe. Now your opportunity, Professor Osamu Kozan. Your time is 5 minutes. Thank you.
Yeah, okay. Thank you. So, Dr. Harris said, yeah, we cannot wait scientific data preparation. But I think Indonesia already have good potential, you know, so BMKG, so meteorological agency, they have C-band radar. Information. And also, for example, now in my research target area, I share elevation data from Shinanoma's company, Shinanoma's APP group. So maybe many company and some NGOs, yeah, they have elevation data. So I hope BRG try to scientific data, integrate assembling and data on the website or a database. So if we can, yeah, of course we can so support and we can share our scientific data in their province. Very good chance. Yeah, this meeting is very good opportunity to discuss this problem. So upscaling is my research target is only a small village. So, but of course we need to upscale our activity. Now we discuss with Kabupaten Bungkalis Regency and company. So more than 7 or 8 village in Kacamatan, same Kacamatan years, or whole Bungkalis Regency and Dumai area. So this is my next step. So yeah, we'd like to share our activity with other provinces also. So yeah, I'd like to discuss so how to share our activity and our achievement in one small village. And can I answer Dr. Kopp's Alex question? So yeah, capillary water estimation is a little bit difficult. So yeah, capillary water sometimes working well, more than 20 centimeters, but sometimes almost no capillary layer. So yeah, depends on how to say density, bulk density, porosity. So yeah, so we even some only 10 or 20 sample, yeah, very difficult to estimate. very difficult to evaluate capillary water layer. So yeah, we also like to discuss with you and other researcher how to estimate, how to usually more than 40 centimeter, more than 60 centimeter is not safety groundwater level, but it depends on soil type and peat type. So we try to how say make index or database using our output. Okay, that's all.
Okay, thank you, Professor Kozan. And the next opportunity is for Pak Susilo Indarto. You have a same chance to give any question, comments, or any suggestion to other speaker presentation.
Yeah.
You have 5 time, Pak Susilo, please.
Thank you, Mr. Putih. I interested with presentasi Prof. Samu. I agree with that R is important is promoting people participation. It is very, 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 very important. I think in PhD run by this area restoration. I am agree with your statement, your presentation. Secondly, Mr. Alex Cox, I agree with canal training makes to composition and fire. Fire is very, very really very in strategy to mix to menghambat apa? Menghambat. To prevent mix canal massively from illegal on community in peatland area. How to hambat itu, to prevent. Bagaimana menghambat supaya menyadarkan, to aware, menyadarkan concession or community around the peatland area to stop make a canal draining. I think that's all, Mr. Putih.
In different places. So does Sabangao have a different parameter than other places, for example?
Yes.
That was my question. Thank you.
Okay, thank you. So you mean the type of land use and the type of peatland should be different character of peat hydrology. So we should use another parameter to estimate the peat fire index. But so more detailed monitoring about peatland hydrology in different land use area and the vegetation area is necessary to more. I think it's and the water in the small power is easy to use for plant. So not only capillary, but also water in small power also important. This is my comment.
Yeah, thank you. And now I think it's about time for the participant to have answered from their question. We have still 30 minutes left, 34 minutes left. Actually, I have to summarize conclusion from all the speakers, but I don't think I will continue with that. I think I will give the rest time just for answer the question from the participant. This is a question from Imam Basuki to Professor Takahashi. What is the effective distance of groundwater level measurement on peatland as required of level prediction to represent the spatially actual condition. Can you give your answer, please?
Usually, many people ask same question. Maybe we should get information from many kinds of land use and land cover. So if there are so many land use pattern in some area, we should monitor a lot. So distance between two sites should be decided by the how in one area. So and I think how we can use the data for estimation and estimation of global wide area hydrology. So distance of two sites should be decided by the land use. It's okay.
Vary between millennials. The condition of the groundwater table is too shallow, so that roots cannot develop due to poor aeration condition. If the organic acid content in pit water is too high, plant growth can also be hampered or even unable to grow due to organic acid poisoning or vice versa. So how is the most appropriate management of peatland that are being managed into agriculture areas where the ages, types of commodities cultivated are different? This is it's not mentioned to whom. Maybe any presenter can answer this question. So please. Nobody wants to answer this question? Okay then. We skip this question first, and maybe we can back later, yeah? And this is from Aulia Agwan. The question is addressed to all resources person. Yeah, to all resources person. Peat restoration, this is the question. Peat restoration is reducing CO2 emission by restoring degraded peatlands. What are important lessons learned from hydrological science on the peat restoration effort that have not been easy so far? Yes, please. This question is addressed to all of the four participants, presenters.
I think you should just pick who to answer, Pak Budi.
Sorry?
You just should pick who to answer.
Yeah, okay. I think Professor Takahashi can answer first, and then Dr. Kopp, and then and so on. Yeah, and the last is Pak Susilo.
Okay, but first, the problem in tropical peatland is a lot of carbon release from there. So the priority of our activity is decreasing or stopping carbon release from tropical peatland. So, but
thank you. Now, Dr. Kopp, it's your turn now.
Sure. I tried to quickly answer. I just give one lesson, I guess. Maybe I can explain more clearly than I did in my talk. I think, to me, an important lesson on the challenges from the hydrological side. Of course, there are many challenges, but from the perspective of hydrology, I think there are two things that make it difficult. One is that peat accumulation is very slow, 1 or 2 millimeters per year, whereas peat loss from subsidence and fire is very fast, maybe 5 centimeters per year. So that's 25 or 50 times faster than peat accumulation. And these processes happen over very long periods of time. So what this means is that a canal or a ditch that has existed for a short time has a long-term impact that continues even after we have filled the ditch or the canal. The impact can last for hundreds of years. So I think this makes it a very fundamentally difficult problem, and that's why understanding the hydrology and how it has been changed by ditches and canals is necessary to try to prevent greenhouse gas emissions and fires in managed peatlands. Thank you.
Yeah, thank you, Dr. Kopp. Actually, this question is your statement in your presentation, so you answer your statement. Okay, maybe Professor Kozan, you want to answer this question?
Yeah, so yeah, my comment is almost same as Professor Takahashi. So yeah, as I said, yeah, scientific data is very important, but sometimes local people, for local people, very simple method is more effective. For example, so every 1 meter elevation zoning or blocking, or for example, now I try to estimate groundwater level using satellite image and drone. So sometimes that kind of simple method is very effective. So we'd like to based on scientific activity, but regulation is should be so for local people.
Thank you, Professor Kozan. Now it's your turn, Mr. Susilo, if you like to answer this question. Mr. Susilo, are you still with us?
The important lesson when we restore about hydrology is how to restoration must be holistic. That every stakeholder and this one KHG is very, very important to doing together. But the problem is one KHG have a close hydrology by corporates and so on, sawit, perkebunan sawit and so on. So we can harus do working group to share water. Sometime in musim rainy season, each concession open the gate the water, so makes floated on under di bawahnya, area di bawahnya. But in kemarau, dry season, all concession in upper area close this close the dam to menyelamatkan, to save this area, and the other upstairs after stream fire dry and mix mudah untuk terbakar.
it would is given how to coordinate one and another stakeholder to working together, not working one by one, depend on their mention yourself. I think something like this. Very, very difficult to coordinating each stakeholder to
Yes,
working together.
yes, right. Thank you, Mr. Susilo. The next question from Surya Tarigan. His question addressed to Professor Takahashi. This is his question. One regulation concerning peat in Indonesia is to preserve 30% of articulate peat as a criteria. Water, is there any methodology to assess how much water this conservation area could potentially provide preventing during the season? That's the question.
So the question is the water in the for example, natural forest, it's one forest, possible to use for another place. Is that it's me the question?
Sorry?
I can not exactly catch the question. So I estimate question is it possible water in the reserved natural forest area is possible to supply to another place? That's the question.
Yeah, I think so. Yeah.
Yes,
Yeah.
that is the question. Yes.
Okay.
This is true.
Yeah.
But I think if the water in the natural reserved forest used for another place, maybe natural forest will be soon disappeared. Because I know in the Sebangau River area, one natural forest was become dry and dry because of water loss from the natural forest. So natural forest keep water for only natural forest itself, cannot use another place. That's okay. This is my question, answer.
Yeah. Thank you, Professor Takahashi. The next question from Imam Basuki again. I think instead of I read your question, maybe you can directly ask your question to Dr. Kopp. Imam Basuki, please.
Yes. Thank you, Pak Budi. To Dr. Alex Kopp, thank you for the presentation. I guess insightful. And my question is about your computation and modeling. I wonder if this computation can help in assessing or estimating the impact of canal blocking or ditch blocking from individual blocking to the surrounding area. Is it possible using your model, and what would be the additional data that you need to accomplish that? That's all my question. Thank you, Pak Budi.
Yes. Please, Dr. Kopp, your time now.
Okay, thank you. Thank you, Dr. Basuki, for the interesting question. I think maybe this will also help to answer the question from Mr. Gunawan. Yes, I think so. I mean, this is part of the reason that I like this approach to peatland hydrology. I think it's simple and easy to understand, and I think it could be useful. The basic point is just that I didn't have time to explain this during the presentation, but the water table surface inside the peatland is smooth. It's the complicated part for us if we were doing peatland hydrology is that the water table is going up and down. So that makes it difficult to see that actually on the landscape scale, the water table is fairly smooth. And so if we can estimate the average water table, we don't need so many measurements to figure out what the shape of the water table is. And we know that the peat surface will either decompose and burn towards the water table or will accumulate towards the water table. So in order to use this in practice, we have the typical problem that we need topographic data, yeah. But I think that in managed areas, so for example, in the peatland hydrologic units, cannot escape this, right? You need the topographic data. Susila was showing us the calculations that he was doing using the peat topography. And so then the trick is to try to figure out how the water table relates to the peat topography. When the canals indigenous, what they do is they take something that starts out as very smooth and create sharp angles. But the water table will still be smooth underneath. So sorry, it's a long and maybe not very direct answer, but if you're interested, we could communicate in other ways. The calculation to figure out the smooth shape is not very difficult. You have to solve a partial differential equation, but it's a relatively simple equation. So I think that it could be used on a practical level, but it would be good to maybe experiment with a single peatland hydrologic unit or something like that to see whether we can use it to optimize the placement of canal blocks, for example. Thank you.
Thank you, Dr. Kopp. Now is your turn, Professor Kozan, to answer the following question. This question from, I'm not sure, Mr. or Mrs. Hanrifda. If you're still there, Hanrifda, maybe you can directly ask question to Professor Kozan. Hanrifda, are you still with us?
Yeah. Yes, sorry.
Sorry, Mrs. or Miss.
Thank you for the opportunity. Yes, my question is as stated in the chat column. I would like to ask Professor Kozan, what are the biggest challenges that you found in involving local communities in peatland restoration and management efforts so far? What were the most difficult parts? And would you say that the methods that you presented earlier, including community water management, etc., are applicable in a large-scale project, for example, in a provincial unit, or instead of just a small village? You mentioned this before with upscaling, but yeah, that's all for me. Thank you.
Yeah. Okay. Thank you. Your comment and question. So. Yeah, community-based management is more effective because, yeah, so, researcher cannot visit frequently there, and now Corona situation. So, yeah, I'm very fortunately now local people can cooperate with company directly, yeah, without me. So, yeah, that kind of system is very effective because company has experience and to have the machine technique, but sometimes their relationship is very bad. But now their relationship improved very well, and that kind of local people's activity sometimes give benefit to company. So nowadays company should do that kind of a cooperative activity, CSR. So now, yeah, company has strong motivation to improve local people's hydrological knowledge or technical support. So yeah, we'd like to continue our activity complete with BRG and other research institutes. Thank you.
Yes. Then the next question address again to you, Professor Kozan. This is again from Surya Tarigan. Surya Tarigan, if you're still there, please give your question directly to Professor Kozan, please.
Yes, thank you, Pak Budi. So when we upscale the water management from village level to landscape level, it will involve more stakeholders, not only farmers, but also private company and other stakeholders. My question is, do you have a suggestion what kind of organization should lead the effort to manage the water for the long term in this area? Thank you.
Yeah, so yeah, I educate many local staff. I hope they will do that kind of activity instead of me. So capek sekali saya sedikit. Yeah, so yeah, I'm a little bit tired to visit almost every month to visit this village. So now, yeah, my opinion. So sometimes local government, local company, villages relationship, how to say? Yeah, local villager is not so strong, so they don't have enough knowledge. So I hope, I don't know, NGO or other organization. So please, yeah, we'd like to discuss. Yeah, we need some, how to say, coordinator.
Yes.
Yeah, coordinator, not local government person, not company person, but yeah, that kind of group or some organization should be better for that kind of management. It's my opinion.
Okay, thank you. Thank you.
Okay. The next question is from Niken Sangkuntala Dewi to Pak Susilo. Ibu Niken, can you give your question to Pak Susilo? Ibu Niken, are you still there? Okay, Pak Susilo, this is her question. How do you prepare for the transition of people's livelihood from dry pit to revetted pit? Thank you. Pak Susilo?
Yes, I think I've answered with apa itu namanya, chatting, with chat.
Oh, you have already answered, eh? Okay.
Yeah, for sure.
Good. Then we can continue. Actually, this is again from Pak Surya Tarigan. But if you don't mind, Pak Surya, I will give a chance to other person, if you don't mind.
I agree, Pak Budi. Please, please.
Yes, thank you. Thank you very much. Yes. This is a question to Pak Susilo again from Muhammad Irfan. How can we do the canal backfilling?
Yes, I think I should answer in with chatting facility.
Oh yes, okay. It will be very quick, eh?
And everywhere can read it.
And also again from Pak Imam Basuki. This question is dan Pak Susilo. Could you please, Pak Imam Basuki, to directly give your question to Profesor Kusamu dan Pak Susilo?
Oh yes, thank you, Pak Budi. I think this has been all answered by Pak Susilo, but I want to further probably to have further elaboration in this. As we know that the pit hydrological unit is a huge area of management, and then what could be done for this as we trying to do effective restoration, for example, rewetting activity to enable raise up the water level in one area, but also not only in one area, but in overall pit hydrological unit, right? What could we do in this? And I agree during the discussion that we need coordination among stakeholders, but yeah, what could be done further? Thank you, Pak.
Yes, Pak Susilo or Professor Osamu, would you like to answer this question?
I think we are not. We can restoration is can finish by PRG only. So all stakeholders must be doing PRG just coordination with all stakeholders first. We can plan to make sub KHG to just a management area to manage area step by step, part of them to complete it and go to another place. So the impacted area, we hope we can target we can target. So we can apa namanya? We can predict it the area impacted of intervention we can predict it before. We can intervene when 1,000 backfill when the canal block backfill, and we can predict it how wide restoration and impact from rewetting. So we must make a TMR to on the good place, special place to measure how groundwater level. So I think something like this. I think, but this is not ideally PRG to restoration. Maybe when expand PRG, maybe 2 periods, we can do it more effective. Something like this. Step by step, I will do how to restoration, ideally restoration. Then we hope research many research we can need to how to impact impact this rewetting restoration. We can our presentation step by step how to restoration, but I don't know exactly what is this impact more penelitian atau for we research. What we research from I don't know exactly too, but more I need a researcher to do it, to check, to research this apa nah the research our theory, our apa lagi kita apa namanya dugaan itu apa nih kita apa Pak yang penelitian itu
Hipotesis.
Iya ya itu saya kirim di situ itu jasanya logical susah sekali asumsikan. Jadi bayangan kita adalah mungkin tolong ditransfer ya supaya enggak substansi samanya enggak supaya mestinya restorasi itu sebelumnya itu bisa mengatakan saya mau membangun sekat kanal sekian unit. dari 500 unit ini, dampak pembahasan yang akan kita lakukan itu sekian hektar. Itu dari perencanaan seharusnya sudah tahu. Untuk itu saya harus merencana menempatkan.
Thank you.
This question to Professor Kozan, but I don't know from whom because it's written in Japanese language. The question is like this: based on your experience, is there any tree plant that have good so that it can improve soil capillarity? Under this condition, under low water table condition, the upper soil will not too dry. So please, Professor Kozan.
Yeah, so how say now I'm not a specialist of plant, so I ask local people and company specialists to select plant depends on hydrological condition. So now and sometimes yeah, local name and scientific name are not matched. So now I preparing how say that kind of list. So yeah, unfortunately I cannot answer now, but I ask so DP biology to detect detect scientific name and growth rate. It means tree growth, tree condition. I ask my friend to evaluate. So yeah, in near future we open our output. Sorry.
Yeah, thank you, Pak
Pak Budi is from me. Pak Budi, can I?
Sorry.
Yeah, it's from my question actually.
Oh yeah.
Okay. So can I explain a little bit to
yes,
Kozan Sensei?
yes,
Yeah.
yes. Please briefly, ya Pak.
Okay, yeah. Thank you, Kozan Sensei. Skosi, sesuatu saya tadi mas. Itu nih. In your presentation, it is interesting. You explain that mineral soil and pit soil has different capillarity in soil. So I believe that if we want to plant something in a peatland area, it should have very good architecture of roots so that the root can go down to get the water. If the water very low, so that the capillarity in soil under pit condition, under dry condition, it would be better. That one character that I think should the plant or the species should have. And the second one, I think the transpiration rate of the above plant should be also very important, so that when under low water condition, the transpiration is very high, then it will also have a problem. So what do you think about that?
Yeah, okay. So yeah, so yeah, depends on so groundwater level and vegetation. Evapotranspiration is very different. So yeah, so for example, now we analyze what kind of process. It's a succession. So first step after burning bare land, sometimes pakis, it's a weed. But if weed became big, in that case, very difficult. A tree cannot grow very well. That kind of succession and evapotranspiration, so measurement already started. And yeah, I'm not specialist, but yeah, local people and some specialists, some fast growing species, for example, Mahang or Makaranga. Yeah, so that kind of special species is very strong and grow quickly, only for 7 or 8 years. But sometimes, but local people doesn't know that kind of species is not, how say, very difficult to sell. It means price is very low. So now I'm learning local people's strategy. Local people know they have strategy. Some of them plant fast growing species. Some of them plant putai, bean. That kind of they can get money only for 1 or 2 years. That kind of yeah, be difficult to answer, but yeah, now we make report. Look, some people the strategy got that kind of output or something. Of course, yeah. So evapotranspiration data is yeah, scientific data. So we'd like to open yeah, this data in near future.
Okay, thank you, Professor Kosan. Yeah.
Mr.
Actually, time is up, but I would like to ask to the committee to have additional time for the next 3 questions. It's okay?
Yes, Pak Budi, please.
Yeah. This question to Pak Susilo from Muhammad Irfan. Saya mahasiswa yang belum bisa menemukan referensi tentang cara menetapkan bahwa groundwater level tidak boleh melebihi 40 cm. Apakah Bapak bisa membantu saya? Saya kira bisa di chat aja ini ya Pak Susilo ya.
Itu saya sudah chat juga sih Pak ke beliau Pak.
Oh sudah dijawab?
Sudah Pak.
Okay. The next question to Dr. Kop from Diah Etika Maharati. Ibu Diah, can you?
It's all. Dr. Kop is already answered the question as well, I think, in the chat.
Okay. Okay.
Yes.
Yeah.
Saya tanya Pak Budi.
Yeah. Nah, so the next question, I give us opportunity to Pak Bambang Setiadi.
Okay.
This directly asked to whom? I don't know.
Dr. Taka, I want to ask
Okay.
you,
Okay.
Dr. Taka.
To Dr. Kasasi.
Hey,
Yes,
Taka
please.
Sensei, how are you?
Oh, fine, fine, thank you.
Great to see you again from 6,580 kilometer. Jakarta, Hokkaido is 6,000 kilometer.
Oh.
You look health and full spirit, and I enjoy your presentation. But I think the era of the Sesame technology is nearly close because this technology is very, very beautiful, very useful for scientists and for the government to monitor water level. But now I think timely to think with you have to what you call that you think about possibility we have to monitor water level on the pit dome. So not on the pit, but special for the pit dome, because the water level on pit dome is more strategic than water level on the pit area. If you can monitor about for instance, about 100 pit dome, then we know what you call the early warning system working to show water is very difficult in this area because water pit dome is very, let's say, it's very small on there. What do you think if we develop another Sesame for
much more expensive course satellite?
Yeah.
So maybe interval of measurement is change from 10 minutes to 1 hour in the case of groundwater level. I think it is enough. So we can cut the amount of data. We can send data from pit dome. We can go get some money to the system. It's okay.
Or maybe you can make another.
Yeah. Yes. Thank you, Professor Takahashi, and ladies and gentlemen. And now I think I will stop this discussion up to here, and I don't think I will read the conclusion because time has exceeded the scheduled time. Thank you, Center, for the excellent presentation, and also thank you to all participants for your attention and your question. And I think I will give the time now back to the committee. Thank you very much and good afternoon.
Thank you, Pak Budi, for very nice moderation, and also to all the presenter for a very enlightened presentation. We really enjoyed the presentation, and we hope that this can last for more hours. However, due to stop and videos, so we can see all the faces, and then I will also ask for the committee to start documenting this this moment. Okay. Okay, I will ask again for the participant to open. Okay, maybe we can start, Mas Fajar, and then 1, and then 2. It's done, Mas Fajar. Okay, okay. Again, I would like to. We are really grateful to have all the speakers and all the audience here. On behalf of BRG, we would say thank you for your participation and for all the active participation here. I would like also to inform that this presentation will be available in BRG YouTube channel. You can just search BRG and then find this presentation. Also about the material, we will also provide it later when with the certificate. Again, yeah. On behalf of BRG, we are thank